Well, hi there, sports fans, and welcome to another exciting edition of Physics 12. Today we're looking at lesson 2.3, which is on friction. And so we will look at friction in a little bit more detail, and more specifically the nature and the basis behind friction, and the fact that friction is practically impossible to eliminate in our world due to the nature of matter. No matter how highly polished you make two surfaces, there will always be some friction between them. And that's just the nature of the way matter was created, and we'll look at that in a little bit more detail in just a minute. Now, although friction works against us, we end up losing a lot of energy due to friction. It also allows us to move in the way that we do. And so if we did not have friction in our world, we would have to find a lot completely different ways of moving around. And lastly, there are two kinds of friction that we will look at, and well, two kinds of friction forces. One of them is what's referred to as static, and the other is referred to as kinetic, and we'll look at that in a little bit more detail today. So first of all, here you have just an example of two objects that are in contact with each other. One is sitting on top of the other, and if you look, if you blow up this small section right here, and you look between their surfaces, if you get right down to the microscopic level, there will always be a rough surface between these objects, no matter how much you think you can polish them and get them, beautifully smooth. When you get right down to the level of the molecules themselves have been created with angles between them. And so you will never get a perfectly smooth surface between two objects, so there will always be friction. And again, as it says here, on a microscopic scale, most surfaces are actually rough. So although they may appear, when you look at them, to be perfectly smooth, when you look at them under a microscope, they actually are very rough. So the exact details are not known, but the force can be modeled in a fairly simple way. And so just by looking at this here, if you look at a microscopic level, and molecules always have angles between them. For example, well, if you just take the example of water, H2O, so you have an oxygen molecule, an oxygen atom attached to two hydrogen atoms, like so, then you can see there are angles there, and so even water, as it flows over top of itself, also has friction associated with it. So that's the basis behind friction, and unfortunately we can't get away from it in our world. That's the way it's been created. But on the other side, then, it's friction that allows us to move. So just as this person may be walking across the floor, it is the force of friction on the floor that allows us to move forward. So it is indeed a friction force that allows us to move. And similarly, with a vehicle, when a vehicle accelerates, it's the friction of the tires on the road that allows the vehicle to accelerate, and it's also the friction of the tires on the road that allows the vehicle to slow down and come to a stop. And so we'll look at that in a little bit more detail in just a minute as well. But once again, it's friction that allows us to move in the way that we do. And if there wasn't friction, then we would be looking at much different ways of moving around in our world. Now, we're going to differentiate between the two different types of friction. Now, static friction is the friction force between two surfaces that are not moving along each other. All right, so in other words, the two surfaces are in contact with each other, and there's no movement between the surfaces. So static friction, it keeps objects on inclines from sliding, and it keeps objects from moving when a force is first applied. So the formula for static friction is given like this. So the friction force is going to be some coefficient times the normal force. Okay, well, how does that work? Well, if you imagine, again, if we have an object here, an object is sitting on a surface here. It has a certain mass to it, and it has a force of gravity on it. If it's not moving in any direction, then the normal force will be the same as the force of gravity. And if you try to move it, so if you try to create some motion in it before it starts to move, you will have a force of static friction. So this is actually before motion. Let me write that in here as well, because that will make it a little bit more clear. So before an object starts to move, and you apply a push to the object, so you push it in some manner, you apply a force to it. Before the object starts to move, that's where you have static friction. So there's no motion between the surfaces with static friction. And that is different then from what we call a kinetic friction. Now, kinetic friction is when two surfaces are sliding between them. So there is movement between the surfaces, and that's what we would call static friction. And in that case, we would write the force of friction then is going to be the coefficient of kinetic friction now times the normal force. And so you can see the forces of friction are obtained in the same way, but we have different coefficients for when the surfaces are in contact or when the surfaces are sliding. So we have static coefficient, and we have a kinetic coefficient as well. So the kinetic coefficient is the coefficient of kinetic friction and is different for every pair of surfaces. And generally speaking, by and large, I don't know of any exceptions to this, but by and large, the coefficient of static friction is greater than the coefficient of kinetic friction. So let's think about that for a moment. What does that mean? Okay, what it means then is that it takes a greater force to start an object moving than it does to keep it moving. And you've probably experienced that yourself many times when you've had to move a heavy object. When you start to move the object, it requires a larger force to actually get it moving. But once you have it moving, you don't want to stop because it seems to be a little bit easier to keep it moving. And so this is indeed why. It takes a larger force to get something moving, so you want to keep it moving. You want to keep the momentum going of something once you have it going as well. But you also, the force of friction when an object is moving is less than when it's not moving. So that explains why, if you've experienced that before, that when you start an object moving, you feel like it's really hard to get this thing going. But once you get it going, it seems a little bit easier to keep it going. And this is exactly why that is. Now, another application of that is, here's a chart of some different surfaces and the different coefficients of friction between surfaces. So we have wood on wood and ice and all sorts of different things here. But what I wanted to point out to you was where we have, first of all, rubber on dry concrete. So let's say, for example, we use the example of a car with rubber tires that's driving on concrete. Now, we look at the static coefficient of static friction for that situation. The coefficient is 1, and the coefficient of kinetic friction is 0.8. All right, well, what does that mean? How does that play out in real life? Well, what that is the exact basis behind ABS systems in a car, the anti-lock braking system in a car, and traction control systems as well. Because the whole objective with those systems in a car is to avoid locking up the wheels on braking or spinning the tires when you're accelerating. Because you don't want to lose the connection of the tire with the road. As soon as you lock up the brakes, you're into kinetic friction. As soon as you get wheel spin on acceleration, again, you have kinetic friction. So you always want to maintain static friction between the tires and the road. And that means then that you don't want to lock up your brakes and you don't want to spin your tires when you're accelerating. When you do, you will lose traction and you will lose performance of the vehicle. And hence, that's why it's much more difficult driving on snowy conditions, because if we look on, or even on wet conditions, we have rubber on wet concrete, you can see that the coefficient of static friction is quite a bit less. Not only with static friction, but kinetic friction as well. And so it's especially important with a wet surface that you don't lock up your brakes or you don't spin the tires, because you will lose a lot of performance. And that's why you need to slow down in those situations. And of course, the situation gets even worse and on icy conditions. This is just an example with wet, dry and wet concrete. So once again, just to recap this, static friction is what you want to have. When you're driving, you want the tire to maintain contact with the road. You don't want to have brakes, you don't want to have your wheels locking up or spinning, because then you're in kinetic friction and you will have a lower force to be able to deal with, to be able to control your vehicle. So this has real life application, and this then explains the theory behind the application of ABS systems in vehicles and traction control.